What are blockchain oracles in cryptocurrency? Oracles provide external data to smart contracts that use blockchain technology. They are, in essence, a means of communication between the outside world and the blockchain world. Oracles provide a safe means of securely supplying off-chain data to a blockchain network's on-chain environment, since blockchains and smart contracts are closed systems with rigorous protocols for connecting to other data sources. But what exactly is an oracle? That is the question that we're going to be answering in today's video. Let's dive right in. Third-party services, known as blockchain oracles, offer smart contracts with external data. They act as a link between blockchains and the rest of the world. Off-chain data is inaccessible to blockchains and smart contracts. However, to carry out numerous contractual agreements, it is necessary to acquire essential information from the outside world. This is where blockchain oracles come in, since they serve as a connection between off-chain and on-chain information. Oracles are important in the blockchain ecosystem because they expand the range of smart contracts that may be used. Smart contracts would be useless without blockchain oracles, since they would only be able to access data from inside their networks. A blockchain oracle is a layer that searches, validates, and authenticates external data sources before relaying the information. Price information, the successful completion of a payment, or the temperature detected by a sensor are all examples of data provided by oracles. The smart contract must be triggered and network resources must be expended to call data from the outside world. Some oracles can also communicate information back to other sources, in addition to relaying it to smart contracts. There are many different sorts of oracles, and how a blockchain oracle works is largely depending on what it is designed for. Some of those designs will be discussed in this video. Example of a blockchain oracle. Let's suppose Alice and Bob are betting on who will win the US presidential election. Bob feels that the Democrat will win, whereas Alice believes that the Republican candidate will win. They agree on the bet's conditions and put their money into a smart contract, which will release all of the money to the winner based on the election results. Because the smart contract cannot interact with external data, it must rely on an oracle to provide it with the information it requires. In this example, the presidential election results. When the election is over, the oracle uses a trusted API to determine who won and transmits that information to the smart contract. Depending on the conclusion, the contract subsequently delivers the money to Alice or Bob. There would have been no way to settle this bet in a fashion that could not be gamed by one of the players if the oracle hadn't relayed the facts. 8 different qualities of blockchain oracles. Blockchain oracles can be classified depending on several different qualities. Source. Does the data originate from software or hardware? The direction of information. Is it inbound or outbound? Trust. Is it centralized or decentralized? A single oracle can fall into multiple categories. For example, an oracle that sources information from a company website is a centralized inbound software oracle. Number 1. Software oracles. Software oracles exchange data with online sources and send it to the blockchain. This data might originate from online databases, servers, web pages, or any other data source on the internet. Because software oracles are connected to the internet, they may not only provide information to smart contracts, but also communicate it in real time. As a result, they're one of the most prevalent blockchain oracles. Exchange rates, digital asset values, and real-time flight information are all examples of information given by software oracles. Number 2. Hardware oracles. Some smart contracts will need to communicate with the outside world. Hardware oracles are devices that collect data from the real world and make it available to smart contracts. Electronic sensors, barcode scanners, and other information gathering equipment might provide this data. A hardware oracle translates real-world occurrences into digital values that smart contracts can understand. A sensor that checks if a vehicle hauling goods has arrived at a loading dock is an example of this. If it does, it sends the data to a smart contract, which may then use it to make choices. Number 3, inbound, and number 4, outbound oracles. Outbound oracles transfer data from smart contracts to the outside world, whereas inbound oracles send data from smart contracts to the outside world. An inbound oracle informs a smart contract about the temperature detected by a sensor. A smart lock may be used as an example of an outbound oracle. If money is deposited to a certain address, the small contract communicates this information to a mechanism that unlocks a smart lock through an outbound oracle. Number 5, centralized, and number 6, decentralized oracles. A centralized oracle is managed by a single entity and serves as the smart contract's sole source of data. Using only one source of information can be dangerous since the contract's efficacy is solely dependent on the entity in charge of the oracle. A bad actor's harmful intervention will also have a direct effect on the smart contract. The major issue with centralized oracles is that they have a single point of failure, making contracts more vulnerable to attacks and flaws. Some of the goals of decentralized oracles are similar to those of public blockchains, such as eliminating counterparty risk. They make the information given to smart contracts more reliable by depending on a single source of truth. The smart contract consults several oracles to verify the data's authenticity and correctness. This is why decentralized oracles are also known as consensus oracles. Other blockchains can use decentralized oracle services provided by some blockchain initiatives. In prediction markets, where the legitimacy of a given outcome may be validated by social consensus, decentralized oracles might be beneficial. While decentralized oracles strive for trustlessness, it's crucial to remember that, like trustless blockchain networks, they don't eliminate trust, rather, they spread it across many participants. Number 7, contract-specific oracles. An oracle intended for use by a single smart contract is known as a contract-specific oracle. This means that if a large number of smart contracts are to be deployed, a corresponding number of contract-specific oracles must be built. The upkeep of this sort of oracle is said to be time-consuming and costly. This technique may be impractical for companies that need to gather data for several sources. Contract-specific oracles, on the other hand, may be built from the ground up to suit a specific use case, giving developers a lot of freedom in tailoring them to unique needs. Number 8, human oracles. Individuals with specialized knowledge in a certain subject can sometimes act as oracles. They may gather information from a variety of sources, check its veracity, and convert it into smart contracts. Because human oracles may use cryptography to authenticate their identity, the chances of a fraudster impersonating them and delivering tampered data are slim. The oracle problem. Smart contracts are essential to a healthy blockchain environment because they make choices based on data given by oracles. The major problem with oracle design is that if the oracle is hacked, the smart contract that relies on it is also hacked. The oracle problem is a term used to describe this situation. Because oracles aren't part of the primary blockchain consensus, they're not included in the security features that public blockchains may offer. The trust problem between third-party oracles and trustless smart contract execution is still mostly unresolved. Man-in-the-middle attacks, in which a hostile actor obtains access to the data flow between the oracles and the contract and alters or falsifies the data, can also be a danger. The global adoption of blockchains requires a trustworthy system that allows communication between smart contracts and the outside world. Smart contracts would have to rely on information already in their networks if they didn't have blockchain oracles, which would severely restrict their potential. Decentralized oracles can add safety mechanisms into the blockchain ecosystem, thereby removing a lot of systemic risks. For the blockchain ecosystem to flourish, oracles remain one of the key building elements that must be deployed in a safe, trustworthy, and trustless manner.